Hi everybody. Today we're going to continue our second part of our trig lesson, which is going to focus on solving word problems involving the keywords angles of elevation and depression. So our objectives are going to be I can solve word problems involving angles of angle, elevation, and depression. So what is an angle of elevation and an angle of depression? Well, an angle of elevation is the angle formed by a horizontal line and an observer's line of sight to an object above the horizon. So if we look to the right, we can see an example of an angle of elevation. So the horizontal line is going to be the line for instance, let's say somebody looks straight ahead, right? So this is going to be the horizontal line. We'll call it HL for horizontal line. Now, it's going to be the angle between that line and the line of sight when you're looking at an object. Let's say in this case, we're looking at an object somewhere up at the top of the tree, right? So I'm looking at this object right here. Maybe there's a bird up there or whatever that is. So the angle of elevation is going to be the angle between that horizontal line and that line of sight. So this is what we call the angle of elevation, right? And whatever angle this is, typically in trig we call angles theta. So whatever angle that is, angle of elevation. So when you hear that term in a word problem, that tells you that you're basically going to create a right triangle that is going to look pretty much exactly like this, right? Let me get a highlighter so we can see. The triangle you're going to make is going to look exactly like this, right? It's going to be a right triangle, and your right angle is going to be right there. All right, let's see what an angle of depression is. So an angle of depression is the angle formed by a horizontal line of sight to an object below the horizontal line. So let's look at that same example here. Right, let's say in this case, there's an object somewhere down here, right? I don't know. There's an object somewhere down here. Maybe there's a cliff, right, where this person is standing. Right, maybe there's a cliff or something, and so now what's going on is the angle of depression is going to be the angle created by the horizontal line and a line of sight going below that horizontal line. So then this angle right here would be the angle of depression. And now we create a right triangle that would look something like this, right? We're going to create a right triangle that would look something like this. So if you notice these two examples, these are the two types of triangles you're going to create. If you have angle of elevation, you're going to create the top looking triangle where the angle is going to be where it's at now. And then if you have an angle of depression, you're going to create a triangle that looks just like the blue one with the pink highlighted. Alrighty, so let's go ahead and look at some more examples. So here all we're asked to do is just to identify which of the angles is an angle of depression and which one is an angle of elevation. So first thing we should identify are what are the horizontal lines, right? So I see one going from F to L. Right, so here, let me go ahead and zoom into this a little bit more. So here is my horizontal line. So that's my HL. Now I can see an angle right below my horizontal line, right? I can see an angle going down from that line. So if it's going down, then this angle is going to be an angle of depression. I'll just call it AOD for now. All right, it's an angle of depression. So that's going to be that one That's going to be that angle right there. Now, if I wanted to solve a problem here, I would create a right triangle out of it, right? That's our goal here. We want to create right triangles out of these guys. So it would look something like that. Let me just highlight this a little bit more, right? It would look something like that. Okay, let's look at the other one, right? I see a horizontal line right here, right? We can see our horizontal line. And I can see that from that horizontal line, right, from this line, the line of sight looking at the helicopter. This is going to be my theta, and this is an angle of elevation, right? I'm looking up, right? I'm looking up. So then I would create a right triangle. My right triangle would look something like this. Okay, so let's look at an example of the angle of elevation and depression. So in this example, we're going to suppose that the sun is going to cast a shadow off of a 35-foot building. If the angle of elevation to the sun is 60 degrees, how long is the shadow to the nearest tenth of a foot? So let's start off with drawing a picture of this. Okay, so we have a building here. Let's go ahead and zoom in a little bit. So it says that there's a height of a building and it's got some sort of shadow. So let's draw some little windows here, right? We've got some windows on my building. All right, maybe they're not all the same size, but that's okay. All right, so there's our building. So suppose the sun casts a shadow off a 35-foot building. Okay, so let's assume that the sun is going to be maybe somewhere over here, right? It's shining nice and bright, all right? And it's going to cast a shadow. Right? Shadows are usually dark, right? It's going to cast a shadow along the floor, right? There's a shadow. Yes, this might look like, to draw 3D, it might look something like that, but we're only going to look at just one line, just to look at it in a two-dimensional way. All right. Suppose the sun casts a shadow off a 35-foot building. So the building has a height of 35 feet. So then this building has a height of 35. So right here, this entire height is 35 feet from here and then all the way down to here, right? 35 feet. Okay. If the angle of elevation to the sun is 60 degrees, how long is the shadow to the nearest tenth of a foot? So the angle of elevation to the sun is 60 degrees. So that means I am looking towards the sun, right? So remember, we want to create a right triangle here. So let's think about what's given, right? We're given the end of the shadow. So from the end of the shadow looking to the sun, this is going to be an angle of elevation right here, right? This is my horizontal line right here. And then this is going to give me your angle theta, which in this case is going to be 60 degrees to the line of sight looking at the sun. Perfect. So now we have our right triangle because a shadow and the building are going to be 90 degrees to each other, and we're looking for the length of the shadow. So this is what I want to find, x. All right, and now I know the height of the building, right? The height of the building is 35. So I know that this height right here is 35. Just make it clearer. So now we have to solve this. Let's use a trig function in order to solve this. Think about what two values you have. This is going to be your opposite side, and then this is going to be your adjacent side. So the way we solve for this is we're going to use tangent. Tangent uses the opposite over the adjacent. So tangent of 60 degrees is equal to the opposite side divided by the adjacent side. Now I'm going to go ahead and put a 1 under this guy. Whoops. We're going to put a 1 under this, and then we're going to go ahead and cross multiply. So cross multiply, cross multiply. So I'm going to end up with 1 times 35, which is just 35, equals x times the tangent of 60 degrees. and then I'm going to divide by the tangent of 60 degrees in order to get x by itself. So that cancels out, and then I divide by the tangent of 60 degrees. So then our final answer, grab my calculator, it is 35 divided by the tangent of 60. Make sure you close the parentheses here. And then we're going to end up with 20.2. I know it says to the nearest tenth of a foot, but whenever it comes to trig, let's always go a couple extra decimals. Let's go to hundredths. So 0 and then 7 feet. Alrighty, and that's what x is going to equal. Okay, in example 2, this time we're going to have to find an angle. So this question says the shadow of a 25-foot tall giraffe has a length of 15 feet. Okay, so the shadow of a 25-foot tall giraffe. So my giraffe is 25 feet tall. So let's go ahead and let's draw our giraffe, right? So our giraffe, let's do our giraffe in like orange. Why not? Okay, I'm not going to draw the whole giraffe. Let's just say that this is a giraffe, right? I'm just going to draw a line. This is his height. He is 25 feet tall, this giraffe. He says he has a shadow of 15 feet. So the shadow of this giraffe is 15 feet. So here's the shadow, 15 feet. Then it says, what is the angle of elevation from the end of the shadow? So it should probably say, what is the angle elevation from the end of the shadow looking towards the top of the giraffe, right? So from the end of the shadow looking towards the top of the giraffe, right? That's the angle of elevation here. All right, that's going to be the angle of elevation. So we have to go ahead and solve for our theta here. So our theta is going to be equal, well, actually, let's just go ahead and write the whole thing out. Well, what do I have here? I have the opposite side, and then I have the adjacent side. So the tangent of my angle is going to be equal to the opposite over the adjacent. My 5s look weird. I apologize. Okay. Maybe if I zoom in, it might be a little bit easier to draw a 5. So 25 and 15. Okay, so now the way we solve for angles, we're going to do the inverse. So theta is equal to the tangent inverse of 25 over 15. And then calculator says that 25 divided by 15 is going to be 59.036. Let's go to the hundredths place, degrees. And we're all done.